Hi, my name is Ivan Ramirez. I'm a customer engineer here with Google Cloud Platform, and I want to welcome you to our Cloud on Air webinar series. The whole month of August, we're going to have a webinar series every single Tuesday talking about different topics that you, as well as our customers, have brought up to our attention. Today, we're joined by Jonathan Cham, who will be talking to us about our machine learning models and how he built his own little demo that we're going to talk about today. So Jonathan, can you introduce yourself?
Yeah, Jonathan Cham. I'm a customer engineer here at Google, and my job is to help customers be successful on Google Cloud Platform.
Okay, great. So tell us a little bit about the inspiration for this topic, which we're calling Hotdog or no Hotdog,
Yeah.
right?
Yeah, so it's twofold. Number one, my wife and I went to a restaurant, and we actually got two different things. We got a sausage. She got like some kind of weird bratwurst sausage dog, and I got a normal hot dog. And when we got the order, we're like, okay, which one's which? Like, we really didn't know. But the second reason is I watched the show HBO Silicon Valley, and they built this hot dog no hot dog app, and I was like, oh, we could totally build this on Google Cloud Platform. And with me, me, I don't know anything about machine learning,
come on.
but ended up building a machine learning model that identifies whether it's a hot dog or not.
And I think that kind of speaks volume as to how easy we make it, right? So you don't need a PhD in to be a data analyst or machine learning expert in order to build any of these models, correct?
Right. I mean, machine learning, I think Google's done a really good job of democratizing machine learning, making it really easy to use, building very high-level libraries that anybody can actually build very useful and meaningful machine learning models with.
Okay, so for those of us who are not too familiar with the Silicon Valley show, can you show us a quick demo before we get started so that we all know what we're talking about?
Yeah, sure. Let's just do a quick demo, and we'll send over the link where everyone out there can also test their own images and try to trick the system. But I mean, Ivan, I think this is a hot dog, right?
I think that's pretty clearly a hot dog.
Okay.
Yeah.
All right. So what we'll do is what we would normally do is upload the image, drag it into it, and yep, it says it's a hot dog. And what is the accuracy?
It's pretty certain it's a hot dog. It's like 99.999%.
Right, 99.96%. I mean, it's pretty confident,
Right.
And it's pretty good.
Oh, I mean, that's clearly a hot dog, right?
Right.
That's not much of a challenge.
Right. This, I mean, what do you think?
Oh, well, I see a lot more things in the image,
Yeah.
so maybe it gets a little tricked. There's what is that like?
Actually, there's a lettuce in the hot dog. I've never had that one before.
That's pretty.
Maybe
really
maybe
interesting.
that's kind of making it really confusing.
But it did say it was a hot dog, right?
Yeah, it did, with a 95 percentile. So,
Okay, so there were a couple of things that were throwing it off there.
Right. And that's kind of the thing that you'll learn in machine learning is a lot of experimentation, a lot of data that needs to, if you don't think this is a hot dog, then you need to basically train the model and say, this is not a hot dog. And maybe it'll identify that lettuce shouldn't be in a hot dog.
Okay, so let's go ahead and talk about what we're actually going to go over today, right? So we're going to go through a brief introduction, which we just did. We're going to talk about just a very high-level overview as to how you made this happen. Then we'll do a deep dive into a code, and then we'll talk about doing a little demo, but not just like we did, but we'll try to actually trick your model, right?
Yeah.
Okay, perfect. So when you begin building these models, what are some of the challenges that you face or that the industry faces, right? When we're trying to make something like this happen?
Yes, I mean, I talk to a lot of customers that are doing a lot of machine learning today, and I think one of the biggest challenges is just having enough compute, network, and storage resources possible. Another thing is having a consistent workflow. One of the problems that we see is different data scientists have, local data on their machines versus machine on cloud, and it's all over the place, right? So creating that consistent, repeatable workflow is pretty much one of the biggest challenges today. Actually, another big challenge is deploying and experimenting and taking what you've done in experimentation mode into production. So that's something that TensorFlow does solve, is making it easy to experiment and then taking that code and deploying it into production.
So we talked about how TensorFlow makes things easy. How does Google make that collaboration easy between the data scientists?
Yeah, so one thing that's really useful is that with Google Cloud Platform, we've built all these technologies that integrate very closely with each other. So BigQuery, Google Cloud Storage, Google Cloud Data Lab, Cloud ML, these things all work together in one seamless interface and enables a data scientist to just quickly get going and deploying their model into production.
The other thing that I think you mentioned was just the scale of it, right? To do machine learning before, you needed rooms full of servers just for the computational needs, but now with the cloud, TPUs, Cloud ML engine, this becomes really easy, right?
Yeah. I mean, it's really about how quickly do you want this to be done? I could run this on my laptop. It might take weeks, months, years. But for most companies, they want to get things done now, and that's where the cloud comes in. That's where having this integration across the different platforms and technologies makes it really useful.
So you touched on it a little bit, but tell us a little bit more about kind of the tools of the trade, right? What is it actually that you are using to put all this together?
Yes, one of the most popular, I guess, machine learning platforms to use in terms of experimentation is using IPython or Jupyter notebooks. And this is something that really aligns itself to experimentation, meaning that you can iterate through different lines of Python code, test things out, and if it doesn't work, then you just go back and repeat, try different libraries, different algorithms. And so we developed Google Cloud Data Lab, which allows you to not only use IPython on our cloud, but also have access to all the other great technologies like BigQuery, Google Cloud Storage, Cloud ML, and a whole slew of other platforms on our cloud.
So before we move into kind of more of a deeper dive into the technologies that you just mentioned and how they all kind of fit together, what if someone's listening to this video right now and says, "Wow, I'm really excited to get started. Where can I find some good resources?"
Yeah, we recently acquired Kaggle. That's kind of where I learned machine learning, just looking through all the open source notebooks. I went through all the code. I mean, these are some of the best data scientists out there that are winning $1 million competitions, looking at their code and seeing what did they do to kind of do exploratory data analysis. Obviously, Google Cloud, we have our own samples and tutorials to walk through. So that would be my first suggestion into just getting familiar with what machine learning is, getting familiar with the different libraries and the technologies that are involved.
Perfect. Okay, so we talked about Cloud Data Lab and how this is a really easy way to use like a Jupyter notebook and leverage all the different tools like the ML Engine, BigQuery, Dataflow to process the data and do whatever you need to do with it. So can you walk us a little bit of how all these pieces kind of fit together, right?
And one thing I didn't mention is that actually everything is open source. So with Google Cloud Data Lab, all those libraries, Google Cloud Data Lab itself is all open source. And that means that if you want to go inside and make changes and manipulate it and modify it the way that you want to use IPython, you can go out there and do so.
And a lot of our customers talk about vendor lock-in. And when they're doing machine learning, I think that's something that's really attractive about GCP.
Yeah.
Open source, if you have any issues, you can move it to any other cloud or on-premise and it's good to go.
Right. And it's got all those built-in libraries. So all you do is you import a BigQuery library and suddenly you have this, this access to all the BigQuery functionality you need to do machine learning.
Good. So walk us through kind of like the high-level architectural diagram of how everything works.
Yeah. So as we saw, we had a very simple web app, and what we did was we would just drag in an image into the web app, and so that's running on App Engine.
Okay.
Right. From a data scientist standpoint, how I built the machine learning model, what we did was we spun up Google Cloud Data Lab. Google Cloud Data Lab is really easy to use. It's 3 words. It's Data Lab, create, and then whatever you want to call it. And that spins up a Google Cloud Data Lab instance, and you can immediately jump in and start using it. And we'll show you what that interface looks like in a bit. Through that interface, that's a really single point of it's your single interface to access all the different technologies. So as you see in this high-level overview, you can access the Cloud ML where I did the training. I stored the images on Google Cloud Storage, and then I did some BigQuery and Dataflow, which we'll describe later in a little bit.
Okay, great. And just for those of us who've never used GCP or just not used to the cloud, how long does it take you to kind of set this architecture up? I know that creating the model and everything might take a little bit of thinking and time, but once you have everything down, how long does it take to kind of put all this together? I noticed that you're using a lot of managed software here from Google, so.
Right. So I come from an infrastructure background, Ivan,
Sure.
and typically I'm setting up the server, installing the OS, patching it, updating it, making sure it's secure, adding all the libraries. I mean, that really took the most amount of time. The beautiful thing about all these different managed services is that there is no infrastructure set up. With App Engine, you just do the deploy app, right? You have an application, deploy it onto App Engine. Cloud ML, also just an API endpoint. BigQuery, same thing, zero infrastructure involved. And Google Cloud Storage, very easy to use. So all of these actually made it really easy to build. I mean, it probably took maybe a couple hours to actually set all of this up. Yeah.
Okay, great. So now that we've talked about kind of the tools of the trade, how they fit together, and just some useful information on how to get started. Let's go a little deeper into how the code actually works and the steps that we took to get there. Okay.
Sounds
so
good.
I'll let you drive this part.
Yeah, so this is the Google Cloud Data Lab. These are just screenshots, but we'll actually go into the actual Data Lab interface in a second. But I mentioned that I use BigQuery. Well, how did I use BigQuery? What did I use it for? There is an open image data set, which is a kind of pre-curated set of images that have been identified that have labels on them. And you can see here that I basically took I went into the open image data set and I identified a label name. So that label name that you see there, 01B9XK, is actually the hot dog label. Confidence of 0.7, and I limited it to 100. So that basically pulled a bunch of images from the open image data set and said that these have a 70% higher confidence that these are actually hot dog images.
And I can already feel the questions on the live feed coming up. Pertaining to the data set size, right? So you told us you just got this data from BigQuery, but how do you know how many images are enough images to make a reliable model? Right?
Yeah, and Ivan, you're not going to like this answer, but it depends, right? It really depends. It depends on how accurate you want it.
Not a clear answer.
No clear answer. I mean, in this example, I only have a couple hundred images because we're using this idea called transfer learning, which is a pre-trained model that is using, for those of you who are maybe more techie, it's an Inception model, version 3, and that model has been pre-trained on millions of images on the ImageNet dataset. So in this example, yeah, we're only using 100 images, and we're grabbing them. Some of these are actually hand labeled. So if you see a confidence level of 1, that means some human being actually went in there and said, this is a hot dog.
So not to go on too much of a tangent, because you just brought up a couple of really good points, but what do you mean by like Inception model?
Yeah, so an Inception model is a pre-trained model, sort of like how if you're going to build a car, you're not going to try to build maybe all the little pieces, right?
From scratch,
maybe the engine, right? The engine you just want to buy out of the box and build everything around it.
Sure.
So with Inception, you can think of it as an analogy, like, hey, you have this engine already that does certain things, and all we want to do is add this extra layer on top of it, which in our case, instead of training it on cats, dogs, animals, and other objects, we said we want to only train it on hot dog or not a hot dog.
Okay, so it's basically the core, right, of the model.
Yeah, it's a pre-trained model. It's got X amount of layers, and there's actually a very famous paper on it that we can probably link to later on what the Inception model is and how it was determined that the Inception model is the best use for for this use case.
Okay, great. So you found an open data set, you got all the images you needed, and you made sure that at least most of them were hot dogs, right? Because it's 70%. What do you do now?
Yeah, so actually we didn't show this here, but I also grabbed images that were not hot dogs, right? So the whole point of training your machine learning model is to have images of your hot dog and of things that are not hot dogs. And my first mistake actually was I just picked 100 random images. I had trains, cars, like chairs.
It's definitely not a hot dog.
Yeah, definitely not a hot dog. Totally accurate. But what happened, what ended up happening was when I fed the model very similar objects to hot dogs, like let's say taquitos, right? It thought taquitos were hot dogs.
So I guess what you're saying then is that you need to be very sure of what kind of data you're putting in so that when you're testing your model, it gives you the answer that you want, right?
Yeah.
So for instance, instead of putting like horses as not hot dogs, maybe you want to put things that may confuse the model, right, in order to train it better.
Exactly.
Okay.
I think most data scientists will agree that your data is your most important asset when it comes to machine learning.
Okay.
Yeah. So, what we did was we found images, and you can tell that in this case we trained it locally and with labels. So we have a bunch of images.
So by locally, you mean on your computer?
Yeah, on the computer. And no hot dog label. And after that, what we'll do is we'll create an object called the CSV dataset, which is basically a combines this CSV file with the schema, where we just showed you that the first column was the image URL, and the second column was the label.
So you're just formatting it, right?
Yeah, it's just formatting.
To feed it into the model.
Basically creating it, putting together all the pieces in order to train it. Here we'll do model pre-processing. Pre-processing basically takes all these images, adjusts them to the specific size, which is, I think in the Inception case, is 299 by 299.
Okay, so actually the image size.
Yeah, the image sizes. And other people do many other things like rotating the images to create a larger data set, changing the colors. I mean, there's a lot of interesting techniques to expand the data set size. But in this example, we're just shrinking it, and we are splitting it into a 70-30 training and test set.
So why would you want to split it into 70/30? Wouldn't you want to use all your data in order to train your model a little better?
Yeah, I think that's kind of like logical reasoning. You want to train it as well as
Much
much
data
as
as you
possible,
can,
right?
right.
But the problem that you find is you train it on all this data, and then once you go into the real world, you have all these samples, and you're wondering, why is my machine model failing, right?
Right.
It's because you never actually tested it on other data, right? You just trained it
Okay.
on all this data. You're like, yep, it's not a hot dog. Suddenly you use images that you've never seen before, and it fails. So that test set allows you to make adjustments and configure it in a way where maybe you can make some enhancements to how the machine learning model will behave in the real world.
I guess it's also the idea of testing your model before you put it out in production with data that it's never seen before.
Exactly,
Right.
exactly.
Got it.
So yeah,
Okay.
so that's pre-processing, and very simple enough. Well, out of that pre-processed step, spits a lot of kind of, we'll call them artifacts, TensorFlow artifacts, puts it into the pre-processing directory. We'll have a batch size of 30 and a steps of 800. We won't go into the specific details of what batch size and max steps are, but those are just parameters that you use. They're called hyperparameters that are used in machine learning.
To train the model.
To
right?
train the model.
Okay.
Yep. So
Okay, so far, kind of just to summarize, we got our images, we formatted them to be the appropriate size, we labeled them hot dog or not hot dog, we're training the model, and what do we do next?
yeah, so I think, let me ask you, what would you do next?
I think I would test it, right?
Yeah, let's test it. All right.
Cool.
So, flour.
That's not a hot dog.
That is not a hot dog, and it's pretty confident, 98%.
Yeah.
Yeah, 98%.
Definitely
Yeah, I
not
think
a
that's
hot
like a
dog.
daisy or something.
Right.
I'm not a
So that's a
flour.
good sanity check.
Yeah, it's a
right?
good sanity check.
It
Like,
would've
hey,
been bad if that
yeah,
would've been a hot dog.
yeah, I don't
Yeah.
think we would be on this thing if
If
it
would've
said
been
it was a hot dog.
Right.
Yeah, but right. So I mean, the sanity check. I think that makes sense to check. Obviously, what we did here was we're just checking the model, we're predicting it, and this is all done in the cloud.
And just to make it clear, we did a lot of images, right?
Yeah, of
Yeah,
course.
This is just an example.
Yep.
Okay, so I guess now let's go ahead and play with the model a little bit and see some of the more, I guess, irregular examples,
Yeah.
right? So we actually went ahead, we used the model that Jonathan built, and we tried to trick it in very different ways. At the beginning, we were successful very easily, which we fixed, and then we started throwing a lot of interesting images into it, right?
Right. So I'm like my own biggest critic, so I really wanted to trick this thing. But this is, I talked about how we took screenshots earlier.
Yeah.
This is the actual notebook.
And
I
we're going to
hid-
make this available.
Yeah,
right?
yeah. I hid some of the code because it's not relevant, but it'll be out there for you guys to look at. So you can see here, we did the training. You've seen all this. This is the sanity check that we did.
Sure.
And so here's when I tried to trick it, right? I said, here, let me give it I don't know, what do you call it? Like a hamburger dog?
A hot burger.
A hot burger, okay,
hot burger.
that works. And I was actually surprised. It actually said it was a hot dog, because I would agree. I mean, there's a hot dog in there.
There's a hot dog there.
Yeah, there's a hot
right?
dog in there.
But I like how the confidence is not as high.
Yeah,
right?
it's not as high.
So it
makes
definitely
sense.
it definitely realizes there's something weird in there.
Exactly.
Right.
It sees, like, recognizes like the general shape and notices a little bit kind of a weird, unusual round part in the middle, but it says it's a hot dog.
Right.
Now, here is where I, tricked my own system into saying that it's not a hot dog. You can see this image here, right here.
Is that 74% confidence
Yes.
that it's not a hot dog?
It's not a hot dog,
It's
right?
not 100% sure it's not a hot dog.
Yeah, I mean, this can be argued, right? I think we can get into a religious battle here about whether this is a hot dog, but I mean, there's a hot dog on a toast. So, model says it's not a hot dog.
So I really love this because then it kind of begins to beg the question, what is it that our model is actually looking for, right? Is it looking for the actual sausage? Is it looking at the shape of the bread? Is it looking at the color of the bread? And I think that's very telling of how we would identify a hot dog versus how the model would identify a hot dog, right?
Exactly.
Right.
Yeah, and let's say, Ivan, you said this is not acceptable. There is no such thing as a hot dog on a piece
On
of
a piece
toast.
of toast, right.
What you would do is you would take this image and put it into the model and say, this is not a hot dog.
As part of
and
the
so
training set.
and so maybe it'll start identifying, okay, if it's got sharp edges around the hot dog, that means it's not a hot dog.
Interesting.
Right. Here's another interesting one where I was able to trick it. These cartoon hot dogs, it just doesn't like it, And I know why. I never trained it on the cartoon hot dogs, but I mean,
you could argue that's not a hot dog, right?
I mean, my daughter would say it's a hot dog.
But it's not a hot dog.
Yeah.
It's a
okay.
picture of a hot dog.
So, we can go offline and argue about that.
And then argue about that, yeah.
But in a sense, this kind of tells you about kind of the experimental nature of machine learning. If you don't like the results, you have to go back in there, throw in more data, and just train it until it's it's to your liking. But these are good examples of, they're kind of hot dogs, not hot dogs. if I wanted to correct all these, it'd be very simple, right? I would just take some of this and just retrain it.
Perfect. Okay, well, Jonathan, thank you so much. I really appreciate you guys showing us this. As we said, the Data Lab Notebook is going to be available for you guys to play with. We're also going to make the app available.
Yeah,
so
we'll send the link over, and then you guys can play with it and try to trick it yourself.
Now, during this entire webinar, we've asked you guys to continue to ask us questions, which we now will go ahead and answer before we go ahead and finish.
Let's take a look. Questions. Okay.
So
it seems that it was very easy. Let's see. Oh, thank you.
There we go.
What skill sets are prerequisites?
So let me go ahead and read the first one.
Yeah.
So it seems that it was very easy to get started with training this model. What skill sets are prerequisites? Python, math, and algorithms?
Mm-hmm. Yeah. At first, I mean, when you start learning about machine learning, one of the things is you'll come across is a lot of math, a lot of calculus, a lot of algorithms. And it's nice to know those because it helps you maybe troubleshoot, right? Maybe you want to be in research and you want to identify better ways to optimize your machine learning models. But in a sense, I'm not perfect at math. I know a little bit about math. And really nowadays, the libraries are so easy to use, high level, and very useful that you don't need to know math. You don't need to know a lot about algorithms. I think Python, very basic, fundamental knowledge about Python is going to be probably necessary if you plan to use Python as your language of choice. There's also other languages like R is also a very popular one in the industry.
So instead of Python, I would say just a programming language.
Yeah. Yeah. I think, but the thing with Python is it's got a lot of support in the community around machine learning, so it's very easy to get started.
And I'll just add, I've also been studying a lot about machine learnings, and the knowing math and algorithms is, like you said, is really nice if you really want to understand what's going on in the background. But necessary to do the training, not really, right?
Yeah.
Okay, so second question. Are there a lot of pre-trained models or for other industries or use cases similar to Inception for images?
I'm not really familiar with that. I know that the most kind of the large competitions that are out there that generate very, very large and very useful pre-trained models are kind of the basic, cats, dogs, whales, ships, trucks, cars. I'm not very familiar with specific industries. I think what I would always like to suggest is take these pre-trained models and just retrain it with your specific use case. Maybe you want to identify, I don't know, a crack in the cement, right? If you're in the manufacturing industry, you want to identify cracks in your goods that you manufacture. You'd be surprised at how repeatable and how useful these pre-trained models can be for your specific use case.
And that's something we actually didn't talk about, right? Right now we're talking about something silly like hot dogs, right?
Yeah.
But talk about like the shipping industry, right? Imagine if we had cameras at the top of boxes, being able to identify defect in boxes before they get shipped out.
Exactly.
Right? That sort of thing is really useful.
Right.
Third question, and this is something that actually I guess we're very excited about, right? What are TPUs?
Yeah, so TPUs are TensorFlow processing units, and just think of them as supercharged GPUs. Very targeted towards machine learning, algorithms, mathematical type of applications, and it's something that we've been talking about it. I don't think we're able to talk about specific dates, right? It's a very sensitive topic. Everyone wants to use a TPU, but if you just do a quick search on TPU on Google, you'll probably see a couple blog posts.
All right. So does the data have to reside in Google Cloud to utilize ML and TensorFlow?
No, that's a great thing about TensorFlow. Open source. We have customers running it all over the place, right? On their, on their local machines, on Google, on other cloud providers, and that's actually something that's really unique about Google is its ability to pretty much open source everything, and it's up to the consumer to decide where they want to run it. We believe that we're obviously the best platform to run your machine learning workloads because of all the different technologies that we can integrate into. But the beauty of TensorFlow is you can run it anywhere.
Right. Finally, are these ML concepts like transfer learning specific to TensorFlow, or do they apply to frameworks like scikit-learn, et cetera?
I don't think that, so transfer learning is just a concept. It's not specific to TensorFlow. I think because TensorFlow is so widely used and so popular that a lot of people have built large models on TensorFlow. I'm not super familiar with some of the other machine learning platforms, but I assume that the idea of transfer learning is just training a model and taking a snapshot of it and reusing a lot of that information to retrain another use case.
Okay, perfect. Let me check. I think we may have, nope.
Oh, that's it.
That's it. All right. Well, thank you so much, Jonathan, for joining us. Thank you for putting the time to put all this together. And please make sure to join us next Tuesday when we talk about a different topic that some of you guys may have suggested.
All right. Thank you so much.